Kevin Blacktop and Stuart Hillmansen, who are actually over at the University of Birmingham as well. They work at the Birmingham Centre for Railway Research and Education, and they are working on a really exciting new project around hydrogen fuel cells and the future of transport, in particular train transport. So hopefully both Kevin and Stuart are there. I believe Stuart is the one that's going to give the presentation, but welcome to you both.
Right, yeah, good morning. Welcome to the presentation about HydroFlex. I'm Kevin Blacktop. I'm the chair of the IMechE Worcester area, and I also work at the University of Birmingham with Stuart. Stuart's a senior lecturer at the university and has been the technical lead for the project. And so we're going to introduce you to HydroFlex. First of all, there's a video to play.
So HydroFlex is the UK's first hydrogen train. It's also the world's first bi-mode electric hydrogen train. And today has been a historic day because it's been the first day we have seen a hydrogen train running on the UK Mainline railway as we left here at Longmarston and went up to Evesham and back successfully.
It takes a lot of work to get a hydrogen train to run on the Mainline. There's a huge amount of safety approvals work that we have to go through. We have to formally document a lot of things, record things, assess the hazards, assess the risks.
Hydrogen is really important in terms of being able to offer decarbonisation solutions to the rail industry, mainly because you can produce hydrogen from renewable sources by electrolyzing water. And hydrogen is going to be used on the parts of the railway which is just not economic to electrify.
I can't describe how proud I am of the whole HydroFlex team to get the first UK mainline hydrogen train working. It's been an absolutely fantastic project, and it's a personal highlight for me as a career, and also it's a real big step forward for the UK and decarbonisation of the railway.
One of the best things about being at the University of Birmingham is we do really, really good practical and industrially focused research, and we've always had a record of doing that. And we developed this partnership with Porterbrook just over 2 years ago, and Porterbrook, from my point of view, have been a really innovative company and willing to take a risk on the technology and working in partnership with us to get to where we are today with the HydroFlex train.
So I'm right here in the West Midlands, where I've just been for a journey on this hydrogen train, a UK first, actually in many senses a world first, train powered only by hydrogen that runs just like a regular diesel train, without the smell, without the noise, and of course without putting out CO2.
It's been so exciting for the team to draw together all that work that we've put in and to see it running at high speed on the network. And more importantly, to the industry to demonstrate this technology is the future.
Right, so that was a video that you may have seen already if you've seen the testing that was announced on the news recently. So we've just started the mainline testing for HydroFlex. So let's give you a bit of background why this is an important development for the rail industry. So why fuel cells in the first place? So if we look at the UK map here of the rail network, you can see that the red parts of the map are routes that are electrified with overhead power lines. And the green in the bottom right-hand corner, the southeast corner of England, that's powered by 750 DC power lines, well, third rail. But all the other routes that you can see in grey are potentially feeder routes for these major electrified routes. And they can be difficult and more expensive to electrify because of topography, curvature of the track, but also the number of trains that will run on those routes. And so electrification isn't always the most cost-effective way forwards. And hydrogen offers the opportunity to for the rail industry to reduce the dependence it has on diesel for these routes. If you look at the air quality requirement as well, diesel has a very high CO2 emissions, and for rail vehicles, the engines are large and they tend to have long lifespans, so that the technology doesn't change that frequently. This means that there's an opportunity to look at other opportunities, and hydrogen offers a zero CO2 emissions solution, particularly if it's generated from renewables. It makes it very sustainable. So how does a fuel cell work? Well, the hydrogen gets pumped in to the fuel cell at low pressure, and it passes, where it passes the anode, the atoms of the hydrogen get separated. The electrons, which are negatively charged, goes around the electric current circuit, and that's where the electricity is generated. The positively charged protons pass through the membrane to the cathode, where the electrons and the protons recombine and also combine with the oxygen to make the byproduct, which in this case is just water and also heat. A fuel cell runs about 50% efficiency, so that means we get 50% comes out as electricity, usable electricity, and 50% goes to the cooling system. This is better than diesel engines, which are in the sort of low 30s in terms of conversion efficiency. Now, a fuel cell, it looks like just a box really, but we've got connections for the hydrogen to go in, connections for electricity to come out. We've also got the exhaust for the water or steam to come out, and a cooling system. And we normally match fuel cells with batteries so that we can make sure that the duty cycle of the fuel cell and battery system matches the requirements for the vehicle being powered by this system. So I'm going to hand over to Stuart now to tell you a bit more about the detail of the train itself.
Thank you very much, Kevin, and thanks for having this opportunity to tell you all about our fabulous project. We started off doing a lot smaller trains, and here you see two photos of fuel cell powered fifth scale locomotives that we developed at the university as part of the Institute of Mechanical Engineers Railway Challenge. And we wanted to do this because back then, sort of five or 6 years ago, we realized there was a good opportunity to use hydrogen as a fuel for railway applications. And the picture you see on the left is our first train, which we actually covered in perspex, so people could see inside it, and importantly see the hydrogen storage and the fuel cell and batteries to give them idea of how the technology is working. And we've kept that philosophy throughout the project, because as at the university, we're all about technological and engineering development, but we're also about dissemination and trying to explain our good ideas to the rest of the world as well, so they can take them up too. Next slide, please, Kevin. So HydroFlex then built on that work, and we developed a partnership with a company called Porterbrook, who own about a third of the railway rolling stock. So all the railway vehicles in the UK, they own about a third of them and operate them in the UK. We have basically had a chat with them and said, can we use one of your trains to develop this technology further? And they said yes. And at Innotrans, which is a trade show, 2018, we signed a partnership agreement and said, let's get on and do this. So we used one of their trains, which is a class 319, which is an electric train. It can take power from overhead wires, which are 25,000 volts, or from what's called third rail system, which is a ground conductor, which is at 750 volts. So it can already take two forms of power input. And our job was to build in a fuel cell power system that would be like a third way of powering this vehicle. Porterbrook have got a good experience of converting these types of vehicles to other fuel sources, and had already done a project where they put some diesel engines on these trains. So they had a lot of experience of having to do this. So we gave ourselves a really aggressive time scale to do this, which was 9 months. There's a picture here showing the team of people involved in doing this, and it very much was a team effort. And as you go forward and go to work in industry and later in your lives, you will probably work in teams. I think from my side, the important part of a team is to recognise that everyone's got a different role. There's all sorts of different characters in the team, and we've got experts in fuel cells, experts in control, experts in project management and procurement. And if you all work together, you can get the job done. But it's important to realise that you fit together like a bit like jigsaw pieces. And if it all works, you can end up with a fabulous team like we have there shown in the picture. Next slide, please. So I want to show you and tell you a little bit about of the detail of HydroFlex as it's working. So the train has got 4 carriages. This is one of the carriages which is in the centre of the train. So at either end you've got what's called a drive-in trailer carriage where the driver sits, and then 2 central carriages. One's got not much in it and the other one's got lots of propulsion equipment in it. And what we wanted to do was, what we did in fact was take out all the seats from this coach, and where the seats were, then we installed the new equipment. And we did this for 2 reasons. The main reason was that it enabled us to put the equipment in a place where we could show people it. So I think since we've developed HydroFlex, probably 1,000 people may have seen the equipment up close, so they can come in and stand next to the fuel cell and we can explain how the fuel cell works to them. We can also show them the hydrogen storage tanks and explain how that works. And also we also have a battery system on the train as well, providing some of the power into the traction system. So it's very modular in the design, and quite simple. There's a lot of complexity hidden behind it, but we can explain the concepts at a very simple level and show people the technology. So as I said right at the beginning, part of our aim is to sort of demystify this technology and to show how it can work and how it can work in a railway application. So you can see there some of the equipment. So I was looking at the left is a control system which has got a computer input into it and some logic signals and auxiliary power supply. Next to that, then going to the right, there's a hydrogen storage tank. Then we've got our hydrogen fuel cell, which then is linked to the 650 volt traction battery and provides current into that. And then both of them share current and provide current into the main traction system, which is sitting below the train. So these are couple of pictures coming up now showing some of the equipment. So the hydrogen is a brilliant fuel because it stores lots of energy per kilogram, but hydrogen gas is very hard to store in itself. So we store the gas in these carbon fiber tanks, which we pressurize up to 350 bar. So that's very, very high pressure. So to give you a comparison, your car tire pressure might be 2 or 3 bar. So we're kind of like 100 times higher pressure than what you would have in a car tire. So the tanks need to be very, very, very strong. And they are made from an aluminium liner that's wrapped with lots of carbon fiber. And then you make a very, very strong tank, which is very safe and can store, in this case, we store up to 20 kilograms of hydrogen on the train. So that 20 kilograms of hydrogen we think could take our train probably up to 100 miles, and bearing in mind this train weighs 140 tons, so it's like 100 cars. We could drive 100 miles with them and only use 20 kilograms of fuel. So it shows you that a fuel cell is actually very efficient and you don't actually need much hydrogen to run it for a number of hours. Next slide, please. And this is the main item on the train, which is the most interesting thing. It's a fuel cell, which we, as Kevin already said, we put hydrogen into it and out comes electricity. We understand how this works, but we're very much users of this, and we just plugged it in, wrote all the control software to control it, and then integrated it into the rest of the train. There's also things like having to handle the air side of it. Also, we need to cool the fuel cell because some of it is not 100% efficient, and the waste energy gets turned into heat, and we need to get rid of that to stop it getting too hot. Okay, thank you. Next slide. And that's the final main item of equipment, which is our battery pack. So the fuel cell works best in combination with a battery. So the fuel cell can vary its power output, but a battery is much better at varying its power output. So the fuel cell and battery work hand in hand, and the battery does most of the really dynamic part of the duty cycle, and the fuel cell kind of provides the mean power for the vehicle. But they work really well together and provide the total power requirements of the vehicle. And you can see there's some of the facts. We run it at 650 volts and got sort of 200 amps coming out of it. So I think the next slide is just a final one saying thank you very much. It has been a really, really fantastic project to work with. And the aim of the project is to make a train which can move under its own power without using electric wires. And you'll have heard today, if you've watched the Prime Minister earlier, he's talking about wind power being a very, very important part of our future electricity supply. So we can use that wind power to produce hydrogen, and then hydrogen can power this train. So we completely remove fossil fuels from the energy mix and can provide sustainable transport well into the future. So thank you very much.
Thank you.
Thank you indeed. That was really interesting. And it's really nice to see what a big complex project like this, how it sort of comes together, and the teamwork that you mentioned that's really important. So obviously people at school thinking about their future careers in science and technology need to also understand that they may well be working as a big team and bringing their own skills to that team, which is really, really important. So when do you think we will actually be able to run on it as a passenger and, maybe travel from Birmingham to, I don't know, Malvern on something like this?
It would be good if it was within 2 years.
Wow.
You think that's feasible?
Yeah, I think that's the sort of timescale we're thinking. We're already working on the next stage of the project, and we've achieved a lot in 2 years, and I think in the next 2 years there's no reason why we can't have a small fleet running on some routes like Malvern to Birmingham, that kind of range, or Stratford-upon-Avon to Birmingham. These routes lend themselves well actually to the type of duty cycle that these vehicles can do.
Exactly. And, that also, as you said, it means that we don't have to start electrifying the line with overhead cables, still be able to use the renewable fuel, which is excellent. I've been looking at the questions. I don't think there's been any questions, even though I did ask if anybody would actually like to travel on one of these trains. Nobody has owned up and said that they would. But thank you ever so much for joining us and showing what this project is like and how it's progressing. And also, I must say thank you to the Institution of Mechanical Engineers as well, obviously, which you're affiliated with and you mentioned, because they're always very supportive. You are always very supportive of the festival. And normally you have a big exhibition stand at the three counties. So it's a shame we couldn't do that this year, but thanks for coming along and showing a real world project, which has got lots of engineering in it. So it's really good to see. Okay, thanks ever so much, Kevin and Stuart. That's fantastic.
Thank you.
Thank you.